Now in question 12, here's a triangle ABC split into two parts by this line. All the information is there. It says that DC is 4. The angle DBC, it says 308. Obviously that means 30 degrees. The 8 should be a degree sign. May well be that the 8 button doubles up for the degree sign under some shift or alternate function. This angle is x degrees. Again, there's that business. Find the exact value of sine x degrees. Again, it says sine x degrees to show that that x is in degrees. It could have been shown other ways because it's just irksome to have to keep writing x degrees all the time. Maybe I'll just concede and do that in this particular one. Right, how can you find x? That means I just want this triangle. There's actually two ways, but just using that scaling triangle, I need some information. Well, the first thing is, this 30 or 30-60 triangle, I know the ratio of sides for that. If I just pop it up here. If you've got a 60-30 triangle, there's the 30, there's the 60, the ratio of sides is 1, 2, root 3. 1 for the shortest, 2 for the biggest, root 3 for the middle one. So this triangle is simply that scaled up by a factor of 4. So if I was to pick out that little triangle, maybe we'll just pop it down a bit. The triangle BCD with the 30 and the 60 in it. Then if that side's 4, it means it's 4 times it. So that should be 8, and that should be 4 times root 3, because it's just 4 times the 1, 2, root 3 triangle. That also gives me this triangle, if I just slice it up here, the upper one that I've removed, which has still got 13 there, but only x there, and that would be the B, and that's the D, and that's the A. If that's 60, that means that's 120 degrees. Now I can work out the length of AD from the big triangle. So if I then take the larger triangle, the complete triangle ABC, with the angle x plus 30 at the base of it, that's 13, that's 4 root 3, so I can work out the length of AC, because that'll just come from Pythagoras. AC squared will be 13 squared minus 4 root 3 squared. That'll be 169 minus, and that'll be 16 times 3, which is 48, and 48 leaves 121, which means AC is exactly 11. So I can then transfer that over there. If the whole length of AC is 11, and that's 4, that means that part's 7. I've got enough information in triangle ABD, so using triangle ABD, in triangle ABD, I can work out the length of work out the value of the sine of x by using the sine rule. So in triangle ABD, I've got this. I've got the sine of x over 7 equals the sine of 120 over 13, just for the simple sine rule. The proportionality between the length of a side and the sine of the opposite angle. So to get sine x degrees, and look, I'm being good and putting it in without getting annoyed, will be 7 upon 30, 13 times the sine of the 120. 120 is equivalent to 60. You can just think of all sine, tan, cos. If you go round 120 degrees, that will leave 60 degrees in a place where the sine's positive. And for the sine of 60, you can get it from the triangle, the sine of 60 is the opposite, so it will be root 3 upon 2. So it's 7 upon 13 times root 3 upon 2. So finally I've got the sine of x degrees is 7 root 13 upon 26. Simply by using the sine rule. Now there is another much longer way of working out the sine of x from this triangle here, which maybe you don't need to look at this, but which I'll do just for the sheer fun of doing it. If I just had this triangle on its own and I wanted to know what's the value of the sine of x, well, I'm not suggesting at all this is what you would do, it's just this is what you can do just for a bit of practice with the addition formula. Because if I had that problem, I would immediately draw in the line which split the x from the 30 and then reconstruct the 30 triangle and take it away to leave the scaling one, just as in the question 12 proper itself. But you could do it from this triangle on its own if you weren't allowed to split it for some reason, just by writing out what that actually stands for. Sine, because I've got this triangle and there's the angle x plus 30. I know that the sine of x plus 30 is equal to the opposite, which is 11 upon 13. And then expanding that, I've got sine x cos 30 plus cos x sine 30 equal to 11 upon 13. You can see where this is going, and I know both of these from the triangle anyway. That's root 3 upon 2. So I've got root 3 upon 2 sine x plus, and the sine of 30 is a half, plus a half cos x equals 11 upon 13. Could get rid of those 2's. Root 3 sine x plus cos x equals 22 upon 13. Call that 1. You can also get cos of x plus 30 from the triangle. That's going to be 4 root 3 upon 13. And then expand that. Cos x cos 30 minus sine x sine 30 equals 4 root 3 upon 13. I know these. The cos of 30 is root 3 upon 2. So root 3 upon 2 cos x minus, and sine 30 is a half. A half sine x equals 4 root 3 upon 13. Multiplying by 2, get rid of the fractions. But I think I'll also do, since I want to find sine, I'd rather eliminate the cos's. So I'm going to multiply everything by negative 2. So I've got sine x, but it will be minus root 3 cos x equals negative m times negative 2 root 3 upon 13 from the second equation. And we'll just highlight those. Oh, I'll box them off totally. I'll make them stand out that wee bit more. We never normally do that. And then, how can I find sine from those? Well, eliminate cos. So if I did this, if I did root 3 times 1 and then added number 2. If I did root 3 times 1 and added number 2 out of this, I'd have root 3 times root 3 is 3, plus the 1 would give me 4 sine x. I'd have plus root 3 and a negative root 3, which means they disappear completely. I'd have 22 root 3 upon 13, and add on this, negative 8 root 3 upon 13. That's going to give me 14 root 3 upon 13. And then sine x itself will be dividing by 4. Well, part of the 4 can divide that 7, the 4 to make 7, and the other part of the 2 can double the bottom to make 26. Same answer as before. Not the way to do it, but just a wee illustration of using the addition formula in a particular triangle.